And you're live.
Alrighty. How do I mute the stream? Am I live right now?
Yeah.
Okay. Yeah, let me mute the stream so I don't hear myself. Alright. Awesome. Alrighty. Yeah, so let's go ahead and get started. I don't know how many people are in here right now, but I'm just going to go ahead and introduce myself kind of briefly. I'm going to introduce who I represent. So my name is Jason Lin. I'm here on behalf of the geoLab at William & Mary. geoLab is a small lab that's kind of been growing in the past year. So we're pretty large right now. And I'm on a specific team within that lab called geoDev. And so geoLab mainly consists of 4 different teams: geoboundaries, geoparsing, geodev, and geodata. Each of these seems like those very different things, but our main focus is analyzing geospatial data with a focus on satellite imagery. And my team specifically, we're the software engineers at the lab, and so we will do a lot of the software consulting for the teams or various specific projects, like research projects within our own team. And some of those projects would be like the Roadrun project, which I'm the undergraduate lead for, which involves applying convolutional neural networks to satellite imagery. Oh, hello in the chat. But anyways, like the geolabs, like we're always looking to recruit more and expand more. And if you have any interest in working with satellite imagery, doing geospatial and data analysis, working with neural networks, and please feel free to apply. I'll send that link in the chat right here. It's a Google form. So go ahead and fill that out. But anyways, like we can go ahead and get started. So I have kind of like a two-parter here today, just on web scraping. And so I'll start like pretty basic, and then we'll kind of get into more advanced, and more intermediate advanced like techniques that you can do for web scraping. And so these slides are actually from a January series that we'd done in the geolab, and that's one of the things we're really focused on, like developing students, having everybody grow and improve. And so as part of that January series, I held 2 seminars. One was basic web scraping, and the other one was advanced web scraping. So this will be kind of similar content, but we can go ahead and get started. So, all right. Yeah, thanks for joining. Hi, Andrew. Hi, Peter. Alrighty. All right, let me click present. Hopefully you guys can still see it. Victor can let me know. Is this all look good? Okay, anyways, I'll proceed. Sure. Anyway, so just like a brief forward. Not all sites want you to crawl and scrape them, so this is kind of like what I'm obligated to tell you. This is kind of like an ethical thing, right? If you scrape a site that they don't really want you to scrape, like you can technically get in trouble. There is a robot.txt or robots.txt file, which it's kind of like just lays out the rules for crawlers and robots, like what you can look at, what you can't not look at, or what they don't want you to look at. But with that aside, like let's get into the fun stuff. So, like our agenda for today, we're going to talk about like first in this first presentation, like what is web scraping, when to use it, then some fundamentals of understanding HTML, and like a basic workflow that will help you kind of how to apply it like an algorithm, and it'll help you like as you work through your data scraping. Then we'll talk about 2 different types of sites, and I'll give you an example on Google Colab. Alrighty, so very basic web scraping. Just want to automatically extract data from sites, and it really speeds up data collection. You don't have to have like all these grunts go to these sites, collect various different things. And if you have a robot do that instead, you can just have it do it. Robots work 24/7 without rest, whatever, it's faster. And so again, like when you want to use it, it's just manually visiting sites. It's really, really repetitive. So let's say within our lab, sometimes we want to extract like all the boundary data. So maybe on our geoboundaries team, we want to collect the boundary information for every administrative area. So we can use a web scraper to very easily download that. Or you want to collect info just across multiple similar pages, right? So an easy example on bottom, you can see Amazon searches. If I want to check the price of like whatever the top listings for clothes are at any time, it's a very repetitive process. I can constantly run like a cron job or something, or job listing searches. And so if the time savings you get from like building a scraper is worth it, then do it. Obviously, like if you need the listing like once for Amazon, do not build a scraper for it. It's not really worth it. But it's just something to consider. Sometimes it's not worth it to build a really fancy scraper. But anyways, yeah, again, if there's an API available, don't look to scrape immediately. Like sometimes you don't need to scrape it because they have an API available and you can just use that API. And it's also more reliable in the long term again, because there's a concept of like resiliency for your web scraping. If you write a web scraper that's not really like resilient to change, and updates to the site might just break it. So inclusion, like if there's an API, use it. But anyways, I'm sure like many of you guys know this, but I'm just gonna go over all the basics and make sure everybody can understand. So just fundamentals, like basic HTML syntax, like you have a start tag and you have like a close tag. So all the content within that is like kind of like a child of that tag. So here we have a tag, we have tag 2, which is a child of this first tag. So if you think of this kind of like a tree, then this would be like a child node of the parent node over here. And everything in here is just the content, like just text, content of that tag. And this is like very, very important to understand, just kind of like you have a tag, you have a sandwich, you have a closing tag, and it's represented by a slash. And here's an example of like actual HTML on the right side, very simple. And so we'll talk about static versus dynamic sites is really important to know. So static just means that all the content is in the page like upon your request immediately. Dynamic means that content can be loaded in after an interaction or a page load. So this can be maybe it's hidden behind a login page, a click to load more, or scroll to load more. Like Twitter, it keeps scrolling, loads more stuff. Or Amazon, like go to multiple pages. So things like that. This is going to be a lot more common in the modern day. Dynamic sites are much, much, much more common. And so I'm going to go ahead and give an example. So I'll drop a link to all these slides again and the geoLab in the chat. But here we go. So in this Google geoLab, like you're going to want to install some prerequisites. I use Beautiful Soup 4. There's many other like libraries out there that can parse, but Beautiful Soup 4 is a really great one, very popular one. That'll just help you parse the HTML from a site. And request is just how we're going to actually access the websites in this simple example. So we're actually going to scrape the Wikipedia page for the College of William and Mary. So here's a screenshot of what the Wikipedia page is. And we want to go ahead and scrape the information from the right side to figure out who the chancellor, president, et cetera, is. And in theory, like something we want to apply to other colleges or whatnot and get all the data. But again, the typical workflow, you got to first visit the site, then you want to identify the information you're interested in. So for us, we want to go to this site and we want to take a look at it and how would we get this data as a human. So then using your developer tools in the console, so it's F12 on Chrome, you can also right click, go to inspect element. And once you're there in that console, so I'll pull it up here briefly, but
actually, Jason, I don't think you have permissions to post links in the chat, so could you escort that to me?
Yeah, I'm looking at the YouTube chat. I don't see any questions. Are there questions in Discord?
Oh, like you can't see if you're posting links in the YouTube stream. I can't see.
Oh, I haven't posted any links. I haven't generated a shareable link for the presentations yet. So again, like yeah, sorry for confusion. I'll make the I'll make all these available afterwards. We'll go over them like first, right, and then you can go ahead and play with them on your own time. So yeah, thanks for that, Victor. I'm trying to keep an eye on the YouTube chat. Hello, Brandon. I don't see any other messages. Alrighty. Anyways, yeah. So we go ahead and inspect element on the thing on the right. This big banner. We can also just navigate to it if we press F12 on our keyboard. Again, it pulls up this thing that shows us like all the different elements going on the page. And so we see it's a table. It has a class of info box and vcard, and it has a style of this. Anyways, and so now that we have this knowledge, like we just make a mental note. This is like what we're looking for. This is what it looks like in just the pure like text representation, the HTML representation. So now we want to get the HTML. So we just go ahead and use the request library to send a get request this URL and go ahead and get that content. So here's a long string. And in this long string is actually the entire Wikipedia page that we're just looking at right now. But obviously that's not really helpful, right? It's just a bunch of text to us, a very, very long string, huge variable. And we want to go ahead and just parse that. And that's where Beautiful Soup comes in. This library is really powerful. It can go ahead and just parse the page into content. And now it's structured HTML. It's able to parse it as a tree. And then we want to filter it. So there's a whole set of functions in there. And here's the Beautiful Soup documentation. just always like head here. There is a guide on how to do it, creating the like soup. But mostly importantly is looking at how you might navigate this tree, get the contents. And so here, like we can usually just use the find, and we find the table class. Well, not the table class, sorry, the table element, and we specify a class of infobox vcard. So we want to find a table element that has a class of infobox and a class of vcard. And so once we found that, we now have our table, right? So as you can see here, we've found it. That really filtered down the HTML a lot, and now we want to extract the data that we've collected. And so just storing in a dictionary, et cetera, we find all the rows, separate them by rows, which is fine. There's also a find all command, so finding all the table rows. And again, like this will be easier if you look at the actual documentation itself. There's various different ways to search, but you can go with just find and find all. You can specify class, you can specify ID, etc. So now we have a list of all the rows. Then we just simply iterate through, and we can discard anything that's a table header. And if we go through each table data cell, we can go ahead and see if it's the content we want, right? And afterwards, we just store it into our dictionary. So in this example, we just very simply navigate to the Wikipedia page. It is a static site, so all the content is loaded on runtime or like request time when you get the site. And the weakness of a scraper like this, where you're making a request to a site, is that it will not work for a more sophisticated site where the data is loaded, again, with JavaScript or other code after you access it. And so you're going to need other tools, which we'll get into. But right now, like, are there any questions? Okay, so Jess was asking, what is the goal of scraping from this Wikipedia page? So again, like this is really for an example's sake, right? I wouldn't consider Wikipedia a reputable source. This is just an easy example of a static website to scrape from. But let's say like it is a reputable source for you. And if you visit pages on like colleges, it is pretty like standardly formatted. Like maybe the UVA site on here on Wikipedia is also going to be in this format. There's a table on the right, et cetera, et cetera. So we can go to that right now. University of Virginia. And here we go. So it is formatted like in a very, very similar fashion, right? And so in theory, we can just go ahead and head to all of these different colleges, or we have a list of colleges. We just search them up and automatically in this bar here. And from there, we can go ahead and pull all the information, or we just generate the URLs in this way, right? Maybe you don't need to have your scraper do it. It's all about just getting the site, getting the data, parsing that data. So that is a really good question. It doesn't have a robots.txt. I'm not actually entirely sure what that implies like there. To me, that implies that there's really no direction for robots. Go ahead and scrape that site. But if they don't say don't scrape my site, then it's fair game, right? It's like Google; they will always index your site unless you say not to. But again, like double check that. So, are there any other questions? All right. Okay. Let's move on to the fun stuff, right? I know this is kind of like a boring introduction to web scraping. So let's talk about advanced web scraping, or a more intermediate thing. So I'll show you guys how you can scrape dynamic sites instead of this simple static site, and we're going to build a more exciting scraper. So we're going to talk about element attributes, how you can select elements in different ways. Then we'll talk about something called Selenium, which is really great for handling these dynamic sites. Then we're going to do an example. We're going to script the Seaboard site. If I pasted a UVA Wikipedia into this scraper here, would it work? I haven't tried, but in theory, yeah, it should work. If it doesn't, it might just need some adjustments to the code to be more resilient to slight differences within the page. So here, it's selecting just directly Yeah, exactly, Joseph. So it depends on how the HTML is structured. It should be very similar. If it has a table with those two attributes and has that data in there, then it will get the data. But let's say Wikipedia decides to change the classes or the class names. The scraper won't work. Again, like you do have the trade-off of lacking that resiliency to change. And sometimes like you have to kind of design for that or account for that if you're trying to build something sustainable. So just something to think about. But anyways, the last thing we're going to cover in our agenda for the more intermediate web scraping is scraping the Seaboard site. So logging in, navigating through it, extracting info, and even interacting with the site. And for those of you who don't know the Seaboard site, like, you'll be in for a surprise. It is very useful for you. If you're a student at the College of William & Mary, it's a very useful site. Anyways, again, just quick review of like the ethics, parsing HTML, and keep in mind this general strategy we have. This is really important. Having this strategy in mind will help you like go through that workflow. You won't be lost. So visit the site, use Dev Console for the area of interest, manually inspect it. So scout things out. Always scout things out before you start coding. Your planning phase. Then extract the HTML, parse it. We did a Wikipedia scraper example. And remember dynamic versus static sites. So we're going to scrape a dynamic site. It's really exciting. Anyway, so an important concept we need first is attributes. So the HTML might have certain attributes that we're interested in versus the actual like contents of a tag. And that's what we did last time. We extracted like the contents and not an attribute. So for example, if you have an anchor tag, right? The attribute here would be the href. So www.google.com, right? But we want to extract this. We don't care about link to Google, the text. We want the href. And so HTML can have many, many different attributes. Can have like style, source for an image, and alt for like a hover name. So attributes are very, very powerful. And it can also be powerful for us to scrape that data if we're interested in it. And so we can extract them in beautiful soup using this syntax. You can index it, or you can just do .get, and both of them will return www.google.com. So you can imagine this is pretty powerful because now we can visit links. All right, another concept we should have is ID versus class. And so these are used for CSS to style HTML elements. So selecting them on the page, you can drop a certain class, you can style that class. HTML elements with that class will receive that style. And so the important distinction between these two is that ID is unique. So keep in mind, if you find ID, it is much more powerful to select by that ID if you want to select only that element. But duplicate IDs will still render, so watch out for bad code. Maybe the developers made a mistake. And fetching element by ID, again, in this case, will return the first match. And same thing for class. So class can be applied to multiple different elements, and that's what really makes it super powerful. Let's say you can make a class for blue. It'll make everything with the class of blue, which is really useful. Maybe I want blue text multiple places on my website. But if I only use the find command, I want to find blue, then I will only get the first one. So that's why you should use find all. All right. But the most important thing to know here is if you have the ID, that is much more powerful than class. That will get you that specific element and nothing more. All right, so now let's talk about Selenium. And it's a browser automation tool. So it's not fully intended to be used for web scraping. You can also use this for unit testing of your site, right? You can have automatic interactions with your website and you run tests that way. So the main advantages of using it then is that we're able to scrape dynamic sites. It is open source and also supports many different programming languages. Today we're using Python, but many other languages are supported. I believe JavaScript is one I know off the top of my head, and I think Java as well. Disadvantages here is that it might be slower, and it does require you to have a supported browser to be installed. So there's several supported ones on the bottom: Opera, Google Chrome, Safari, Firefox, Internet Explorer, and Microsoft Edge. And today we'll be using Google Chrome, just because that's the most popular browser, or maybe it isn't now, but it is a browser that we'll be using just because it's popular. And because you have to run an actual browser, that's why it'll be a little slower. Selenium will actually fire up your web browser and visit it. So just how you install, just pip install as usual. But again, like I need to mention this, you have to install the Selenium WebDriver matched to your browser version. And so they have detailed instructions on the site. So please visit that if you're having trouble. So again, example time. Alrighty, so Seaboard Scraper. So if you guys don't know what Seaboard is, this is this site. It is for trap card services, and you can come on here, check your balances, your Express, your Flex, your meal plan. You can also go ahead and check availability of laundry, things like that. So this is really great site if you're trying to check how much money you have, or if you want to change your meal plan. So many of you have seen this page before, but it is a really good information hub. And so here we're going to go ahead and in this scraper, our goal will be to scrape all the laundry data of every machine, because that is really, really valuable data. Knowing like when the laundry machines are available, who's using the machines when. Let's say I'm interested in that data, right? And so again, we'll set up our environment. We'll install soup, Selenium, etc., etc. So again, we'll navigate to the site first, just like you would as a human. But one important thing here, so I want to highlight this line right here. Chrome options that add argument headless. So sometimes it is good to have it in headed mode, which means that it will literally open up the Chrome browser in front of your face, go to that site, run everything it's done, just click on everything, and you can see it. It's super cool. Your hands are off the keyboard and it's going to the site and doing all this. But the problem is it's really slow because your screen has to render everything. Their browser will have to show you all these fancy pictures coming up. If you do headless, who cares about all of that? Like, it's not going to render any of it. So it kind of saves you a little bit of time, and it can improve performance. But here you can see it's loading up the Chrome driver. A lot of the code here is specifically getting it to work with Google Colab, and so it will look different if you're doing this on your local machine. And so we're going to go ahead and log in, right? So when you reach the site, you see a login option. Click to log in. So now we have to get through William Mary's central authentication system, right? And so the first hurdle for us will be clicking on this button. For us, like as a human, we click on the button, right? But for the computer, it needs to find the button, then needs to click on it. So if you think about it, those are the exact steps we do as like a human. So think about like your actions at a more granular level. It's like the how do you make a peanut butter and jelly sandwich? Think about every single step very, very, very much in detail. So here, I have to go ahead and find the button, then I click on it. So that's exactly what we do here. We use our selectors to go ahead and find it, click on it, and it'll take us to this site, which I have to log in. So Google's already autofilled that for me. But here, I need to go ahead and find this box, type in this, find this box, type in my password, and find this button, and click the login button. So you can fill in boxes just by selecting them as you normally would. And so once you have that element selected, don't worry, here's just in this code, like I'm still getting my password. I'm like, I don't really want to give you my William Mary password, so forgive me, it is right here, has dots. But anyways, you can very easily find elements by ID. So remember that concept of ID versus class, right? We'll do an inspect on this site, and you can see that there's an ID of username. And so when we see an ID, we know like we've got it, we can easily select it. This is a unique attribute. And when we find it by ID, we can guarantee that we have this box and nothing else. And then to fill out boxes, you can use the send keys method. So send keys just sends a text. This is how you fill it out. So after you run these two lines, you should have exactly what I have here, which is Jalen10 and my password in here. Well, or your username password. Then you find the submit button. So I find it different here because I wanted to showcase the ability to use a CSS selector. So there's a whole list of CSS selectors. If you Google just CSS selectors, there's a whole guide that will run you through what they look like. That's for selecting HTML attributes when you're actually creating a cascading style sheet. If you want to apply blue to specific buttons on a website, things like that. That's for web developers. And then clicking a button, .click method. So again, finding it, doing whatever you want with it, then clicking it, doing whatever. So just a sanity check after here, and you can see that we've logged in. So afterwards, okay, we'll let that log me in slowly. But after you're logged in, there's a little menu on the left. I don't know why it's taking so long. Login failed. Okay. I guess central authentication is down right now or something. Okay. Anyways, couldn't log into the site. There's a bug or something. Anyways, when you navigate to the site, hopefully everybody in the chat has been there before. Sorry, Joseph is saying something in chat. Let's see. Joe. Yeah, I can show I got the HTML for the button. Let me go back to that site, even though cast failed. So oh, there you go. I just exposed my dining dollars. It's okay. So getting this right here. This is just multiple classes chained together, right? So if I were to go to central authentication, let's go to Blackboard, I guess. It'll ask me to log in. Okay, or I've already been signed in. It's a HTML tag. It's an element called input, and it has these classes button block, and button submit, and they're just Bootstrap like classes. And so the way I got them was, again, I used the developer console. I right-clicked on it, inspected element, and I noticed that it was this element with these specific classes. So in this way, I can guarantee that I select the button. Yeah, and it says exposed. Yeah, I leaked my $208 dining dollars. If anybody needs a Flex Daddy, come find me. Anyways, let's continue. So I think it is working now. So on the left, you can see all these options. So we want to be able to go to this menu and actually select the laundry button. So again, there's multiple different ways we can do this. And so here we're going to just use a convenient method in Selenium. So again, we're not using Beautiful Soup to find these elements. Selenium has a whole array of find methods, and you can just find that with a Google search and find like all the different ways you can select it. It's also in the documentation, just in a nice format. And so find element by link text is really powerful. There's also find element by partial link text. So because the link says laundry, we find any link on the page with the words laundry. So once we have that, we can go ahead and get the attribute again of href, which is what this links to. So we'll inspect it. And here, ahref equals students laundry welcome.php. So this is the page that it's going to link to when you click it. Or we can just click it like a normal human. So after we click it, we want to go to the room status. And then here, since I have favorites, it'll show the Landrum laundry room. All right. And so because maybe there's favorites, right? For me, there are favorites. Then you want to use partial link text match for all rooms, or just a full match for all rooms. But maybe now here you have to think about some error handling, right? So for me, I did some error handling because maybe I don't have a favorite and it is unable to find the link text of all rooms, because notice that this is no longer a link once I go away from my favorites. And so here, like you're seeing some elements of this. This is a dynamic website, right? And if you actually try to script this in a static way, you can actually get to this page. Unfortunately, none of the laundry rooms will show up in that static page. You'll just get some HTML. It'll be everything except for like it will be everything except for the data you want. So I think you will get like this text, but you won't get like this. So we can actually see that in the page source. Here, if you look at the page source, there's not a single laundry room in the page source, right? And this is a problem if we're scraping it with the request method that I showed previously, that we used to scrape the Wikipedia site. So that is why we use Selenium. Oh, Joseph's asking, what is Bootstrap? Yeah, so I mentioned some of these Bootstrap classes earlier, and Bootstrap just call it framework, just collection of methods. It's provided by Twitter. So what else we'll use a lot, you can add it to Bootstrap CDN. So here you go. Here you go. You can just add it to your site. It just helps you like develop faster, pretty much. Like get cool layouts, grid layouts, pre-built elements like carousels and stuff. Anyways, we follow through, go through room status, go to all rooms, and now we have the data we want, right? So everything on this page looks right. The data we want is contained on this page. We see availability, 3 out of 3, 1 out of 1, 3 out of 3, 2 out of 5. 3 people are drawing their close-in Landrum as we speak. And so now we have all this, we can leave Selenium and download this entire site. So download all the source and go ahead and head into beautiful soup. So we'll parse it. Here it's a little different. So I'm using HTML.parser over the default LXML.parser. So this is how it parses the string that you feed it, and it parses that as into like a tree. Specifying HTML.parser is stronger because there actually is an error on this page in the code. So this is an invalid HTML. There's something's wrong with it. I don't know exactly where, but if you use LXML, it will fail because somewhere it's gone wrong. But this one's a little more resilient, a little more robust. So we want to find all the rows with row 1 and row 2 attributes. So here, we're going to inspect the table. So table border, okay, very nice. Table body, and it seems to show. So for me on Google Chrome, it will highlight every element that I'm hovering over in the tree. Table body, this is everything I want. So table row, okay, I see. This is a header, okay. Another table row, okay, it's another header. So these don't really have attributes, but I notice row 1, row 2, row 1, row 2. So it seems every table row with these classes contains the data of interest. That is a pattern that I'm looking at. A lot of this is pattern identification, and like it comes with practice, and I'm sure like you guys are pretty good at identifying patterns as computer scientists already. So here we go. TD stands for table data, and TR stands for table row. So you'll hear me say that a lot, but we're here within the table row of class row 1, table row of class row 2. And so just for like the sake of knowledge, I guess, the reason why they're row 1 and row 2 is if you notice different colors, they want to apply the different colors to each of these elements. But we can use that to our advantage, right? So for us, we can find all the table rows with that specific class, row 1, row 2. Find all of it, row 1, row 2. So we didn't even need to filter it down to table body. We can just find it on this whole entire page. There's no other content. But if there was, we would want to filter down our HTML to just the table, again, like we did in the previous example. So here, I just want to store the data and just parse through. Here, it's not done in the most robust way. If they update the site in any way whatsoever, it will break, and that is something to watch out for. So there isn't really anything that identifies each of these except for like the table header. So maybe if you were to be more robust with this, instead of just quickly running through it, you can read the table header, identify the table headers somehow in a robust way, then use these to act. But anyways, like here, I know that always the first item is the name of the laundry room. The third item is the washer availability. The fifth item is the dryer availability, and that's exactly what I do here. So I grab all the text and I go ahead, all the cells, all the table data, and I just find it based on its relative position within that row. So you can see washers, dryers, and just a number, just an index, and split the data up again. So this is more like data processing, string processing, etc. And so at the end of this, we can see that we have every available dryer, every available washer, its location. and the total dryers and the total washers. So this is pretty powerful, right? We got exactly what we wanted. Joseph's asking, what do you mean by a robust way? So when I say robust, I'm saying like something that's more resilient to change. If the developers of this site had updated it and maybe they're like, I want washers and dryers. I want this to be alphabetical. So they put dryers here and they put washers here instead and just make that minor change, right? As a human, like, doesn't really matter. Maybe you use the site a lot, you get confused by it, but not a big deal. Or maybe they add an extra bar here, right? Like an extra column. Or like email me when available or something like that. If your scraper follows this pattern, right? They add an extra column, remove a column, it will get the wrong data. And that could be a big issue. So that's what I mean by a robust way. But as you can see here, like we've managed to pull all the data like as of now, so it is working right now. And another fun thing to explore, like from this point on, is you can click on each of these laundry rooms. Hopefully I didn't time out. Hello. Okay, you can click on each of the laundry rooms. Okay, populates at the very bottom of the site. And it shows you each individual one, the amount of time left on each one. So a lot more data down here. And so it could be worthwhile to scrape all this data. So I'm going to open it up to any questions that you guys might have. Feel free to ask anything in the chat. It can be about web scraping in general, like any advice and tips, or you can ask about the geoLab, which I am here on behalf of. So. All right, doesn't look like I have any questions. Kind of just, if you guys want to put like a thumbs up for web scraping in the chat or something, that's also fine. But I'm gonna go ahead and share all these slides with everyone. All right, so I'm gonna put that in the chat here, and I can send that to Victor, and he can send it off to you guys. But that is all I had tonight. So thanks for coming. I hope you learned something. All right, Victor, you here?
Yep.
Alrighty, so I think that's pretty much all I had.
Yep.
Oh, yeah. So just saying, what's one example of how this can apply to the hackathon? Okay, so funnily enough, the Seaboard Web Scraper is really similar to a hack that I did with my teammates in my freshman year, and that actually won an award, right? So I pulled all the laundry data and we put it on an Alexa called the Alexa. So the goal was to check your student like flex balance, your express balance, your meal swipes. So you could ask that Alexa what all of those balances were, or you could also ask it the availability of the laundry in your room. And that's an example of how web scraping might help you. Yeah, so the current script right now only creates an instance of the data at a certain time. So a little bit more information like on this script, I actually am running this on a platform that we use in our lab, and I'm scraping the data just because I'm interested in it. And I've been scraping the data for the past like month or so, and so I have the laundry data of every hour from when I started it a month ago of the student laundry, and that's time-stamped. So yeah, there's a lot of things you can do with web scraping. Are there any more questions? Yeah, so Seaboard is dynamic because they use PHP to load in the data from their database or their systems or whatnot. So they go ahead and load it onto site versus having it there initially. When you send that GET request to the server and it sends that web page back to you, it's not the same. So it loads the site, it loads the data afterwards onto that site to be rendered to you. So if you were just to use the requests library to get the page source, you wouldn't see anything. And I showed you that with the page source versus what the page source looked like in the console. Anything interesting from the data? The best time to do your laundry is Wednesday afternoon. Never do your laundry Sunday afternoon or Saturday afternoon. So nothing really new, but it's actually funny because this semester, at least, people really love doing their laundry on Monday, starting from the afternoon. So it's about the same as Thursday and Friday, a little more, so kind of in between Thursday and Friday. But yeah, so figured out the best time to do your laundry. I think there will be much more interesting data once more people are on campus again. But yeah, that's all I had. So thank you so much for joining me. All right, so Victor.